So this is Newton's second law reassessment, and Newton's second law says the sum of the forces equal mass times acceleration. The problem is you apply a force of 5 newtons horizontally to a 1,627 gram book that is at rest on a horizontal table. If the force of friction between the book and the table is 3.6 newtons, what are the magnitudes of the forces acting on the book? So I drew my free body diagram, and I have a force of gravity, a normal force, since the object is in equilibrium, and a force applied this way, and then I have my frictional force since the book is moving this way. So I know my force applied is 5 newtons, my frictional force is 3.6 newtons, my mass is 1,627 grams, which I converted to kilograms, 1.627 kilograms, and my initial velocity is 0. So right here, force of gravity equals mass times gravity. So I did that and got 15.961 newtons, and so the sum of the forces in the y direction equal the normal force minus the force of gravity, because it's in the negative direction, equals mass times acceleration in the y direction. And the acceleration in the y direction is 0, so anything times 0 is 0, which gave me the normal force minus the force of gravity equals 0, which led me to the normal force equals the force of gravity, which equals 15.961 newtons. The second part of this problem is, what is the acceleration of the book? So the sum of the forces in the x direction equal the force applied minus the frictional force, because frictional force is in the negative direction. Am I covering up the microphone? Equals mass times acceleration in the x direction. And so I solved for acceleration, and that gave me force applied minus force of friction divided by m. So I divided by the mass on both sides to get this equation. Then I plugged in what I knew, went back up here to reference that, and got 5.0 minus 3.6 divided by 1.627, and that gave me 0.86 meters per second squared. And that is my Newton's second law reassessment.